Bismillahirrahmanirrahim. Cost Hatha model is a radio propagation model. Like many other models we have already discussed. And this model is an extended version of Hatha model. And Hatha model is the improved version of Akamora model. So in today unit, we will discuss firstly cost Hatha model. And then we discuss the coverage limitation of the cost Hatha model. And finally, we will discuss in detail about the empirical relation of the cost Hatha model. This model is an extension of the Apanhata model, as we have already discussed. The main objective of this model is to cover the more extensive range of frequency up to 2 gigahertz. The Hatha model, basically, it is also known as PCS extension model. It is also known as COS231 model. Actually, COS31 model is most cited and frequently among many bundle of COS231 models. So, which were funded by the European Union between 1986 to 1996, I think, for the purpose of estimating path loss in urban areas. Over a frequency range of 800 megahertz to 2000 megahertz, this model is the combination of both empirical and deterministic parameters. Cost, which is stand for some French name and for cooperative scientific research with the name of Forum, that is the part of the European Union. It is responsible for developing this model and which is based on experimental measurement acquired in number of cities, and mostly these cities are located in different parts of Europe for accuracy and high quality of efficiency. Like all other empirical models, all such a model also has some coverage limitation. And for frequency response, it works from 1500 to 2000 megahertz. And a mobile station antenna should be height from 1 to 10 meters, while base station height from 30 to 200 meters, and length distance from 1 to 20 kilometers. This model required that the base station antenna is higher than all adjacent rooftops. It is worth noting that while the other model can provide a starting point of coverage planning, especially in the urban and suburban area, it is advisable to validate the model's prediction and field measurement or consider more advanced propagation models for enhanced accuracy, particularly when dealing with a frequency outside the model's original range or sometimes very complex propagation environment. Before stating cost Hatha model, it is important to note that Hatha introduced some variables like many other models in the Hatha model. And the cost Hatha model introduced five factors to calculate LB as a medium path loss with unit decibels. He introduced frequency, which is denoted by M, and HB, which is a base station antenna effective height. Similarly, another factor E, which is a function of HR and frequency, where HR is the mobile station antenna effective height and separately correlated for rural as well as urban areas. That's why I introduced a factor CM to identify cities as medium cities, suburban cities, and metropolitan cities. So he introduced LBS is equal to 46.3 plus 33.9 log F and minus 13.82 log HB over M minus A, which is function of HR and F, plus let me start 44.9 minus 6.55 log HBO and bracket close log B over KX, which will mean that D is in kilometer plus C. Here he defined F in megahertz, HB in meters, and HB are meters, and D is in kilometers. And where alpha is defined for alpha, sorry, A is defined for two frequency range for urban area and for suburban area. It covers all frequency, given frequency range, where alpha HRF can be written for rural areas is equal to 1.1 log f minus zero point 0.7 and HR minus bracket starts 1.56 log f minus zero point 0.3, which is close. But for urban area, we divide two frequency range. One is from 150 to 200 range, and from 200 to 1500 megahertz. For 150 to 200 megahertz rates, he defined area as 8.29 log 1.54 HR square minus 1.1. While for frequency 200 to 1500 megahertz, he defined A as a 3.2 bracket start log 11.75 HR and all R square minus 4.96. And similarly, CM factor, as we discussed earlier, we defined for BDM cities and suburban areas. So CM is equal to 0 decibels. But for metropolitan area like Tokyo, CM is defined for 3 decibels. So this is the total behavior of last empirical model, which is we consider mostly cited model among the other cost model introduced by the cost not review.